Hey guys, let's do a rock, paper, scissors game. Some of you right now should just go try it. Like using what you've learned in Number Guesser, how to get random numbers and stuff like that. You could probably do it right now and how to cast, I guess. Some of us are going to need a lot of help. So I'm going to look at my old Python handout. It says create a rock, paper, scissors game that accepts some numbers for rock, paper, scissors. Includes methods. We don't know how to use methods yet or functions. But we're going to find out who the winner was, okay? So, yeah, just think. Have you ever played rock, paper, scissors? Can I make that in a computer game? Let's go start a new solution. I'm not going to call it rock, paper, scissors. I'm going to call it RPS, I think. So this is, what is it? Z drive, grammar, find your folder, and say OK. And let's call this project Mono4B, I think. RPS, rock, paper, scissors, okay? I'm going to hit OK. Let me go make sure that's the right name. I think it is. Yeah, it'll be 3C. Okay. So right off the bat, instead of hello world, I want to say choose weapon. And like you could choose how to do it. They could type in strings, right? Rock, paper, or scissors. Okay. Now the next question is, once I say that, if I run this, it says, hey, choose a weapon, press enter to continue. We never got it from them, so how do I do that? I use console.what, read line, I need to get it, and I need to put in a variable. But this is about as far as I want to go before I start planning better, okay? There's tons of things I could do wrong. I could give the wrong input, I could try to break it, type in, Spock or bomb or something, but let's just assume everything's going to be right and that they're not going to type in anything weird. Let's just try to make this game as simple as we can to start off with, okay? And I'm not going to show you 1,000 different ways to do it, like rock, paper, scissors. Try to keep it pretty straightforward, okay? So let's go make some comments. Let's do some pseudo code, and I keep saying that it's just a pseudo code, but let's plan. Get rock, paper, scissors from the player, and get rock, paper, scissors from the... And let's not make this a two-player game, because obviously if player 1 sees what player 2 typed, they'll choose the opposite. So let's make it against the computer and check the answers. Okay, so again, when we start making bigger projects, it's essential that we plan. So this first part of my program is going to be get the rock, paper, scissors. And you know what do we always do first in a C# program? We first always declare the variables we're going to use in our program. Why? Because we always have to say int, string, blah, blah, and then later on we use them, okay? And it's also nice if all the variables are in one place, because that way, we know what variables we're using in the program. We don't have any question about it, and if we want to erase one or change one or anything, we just look in one place rather than having them scattered all throughout our code, which is really ugly, as hopefully you saw in the last Number Guesser program. So, okay, so declare the variables. Well, let's start with a string, I guess. String, human choice, player choice, and string computer choice. Okay, and I don't know, I guess we're just going to type in rock, paper, scissors from the beginning, and you might think, yeah, let's do that. But we need to start thinking, how is the computer going to choose rock, paper, or scissors? Okay? And you're like, oh, that's kind of a pain. So let's go to the player one first. I'm just cutting and pasting stuff all around. Okay, let's see if this works right. If this is the right order. Make some variables, get the player's choice, get the computer's choice, check the answers. Some of you might think immediately, oh, wait a minute. If we choose first, the computer can cheat. And they sure can. And that's actually one of the hard parts in AI, is not using too much information to always beat the player. You have to try to use a little bit of information, but not too much. If you know exactly where they're moving or what they're doing, you could kill them every time. But the computer tries not to cheat too much, but still be semi-informed with a little bit of randomness in there. So let's go string human choice, and then they type in rock, paper, scissors, and everything worked fine. string computer choice. You know what? Hopefully some of you are thinking, well, the computer is not going to be able to choose with a string. The computer is going to have to choose a number 1, 2, or 3 using random number, just like we did in Number Guesser. Okay, so let's make human choice an int 2, and let's just make our lives easier. 1 for rock, 2 for paper, or 3 for scissors. Okay? And let's say choose a number, just so they don't think that there's anything else weird about it. Okay. And you might want to put dashes here. I don't know what you want to do. Just make it pretty. 3 scissors. Okay. So we read line. Let's store it in a variable. Where does this go? It's going to go in. And hopefully you're like, oh, wait a minute. Human choice isn't going to be able to store read line, because what does read line give me? It gives me strings, and human choice is an int. So let's run it, and it says, hey, I can't convert a string to an int. And we could make a third variable, human int and human string. That's going to make our life harder. Let's see if we can just cast directly right off the read line. So remember that we can still do stuff with read line, okay? And I'm going to kind of jump ahead a little bit. We don't know all the string actions yet, but I'm going to show you how you can find them, okay? You do any string, Bob, or even an empty string like 2 quotes. But if you go Bob dot, you see all the stuff that's built into C# that you can do with strings. Okay, let's go see if I can go 3 dot. No, that's like 3.14. It doesn't have it for ints, just for Bob, just for strings. I can clone a string. I can compare a string. I can see if a string contains something. I can copy a string to another string. I can see if it ends with certain characters or ends with a certain string. I can see if it equals a string. Some of these gets are a little confusing. I can find the index of a certain letter. I can insert something into it. I can find the length of the string. That's pretty important. I can put padding on it or spaces. I can remove stuff. I can replace stuff. I can split the string. I can see if it starts with certain stuff, certain letters. I can convert it to a character array. That's pretty cool. I can convert it to lowercase, to uppercase. I can trim stuff off of it, okay? So did I see anything in there that said to int or to number or casting? No, I didn't, okay? So I don't know why I just showed you all that. Well, I'm not going back. What we are going to do is instead cast it, okay? So how do I cast a string? I go int dot parse, and what do I want to cast? I'm going to put some spaces here because I want to show you that we're casting or parsing, converting whatever came from console.readline. Remember, this is a string. If they type in Bob on that read line, this literally turns into Bob. And I've said that 100 times, and some of you still are not quite getting it, that console.readline returns a string or becomes a string that they typed on the keyboard. Okay, so can I parse Bob? I sure can, but I can't parse it to an int. That'll crash, but I can parse the string 1 to an int. So let's back up, and hopefully they only give me integers. Again, later on we're going to learn how to fix stuff if they type in the wrong words, if they type in ONE instead of the number 1. But let's see if this works. Run it, choose number 1. Okay, it doesn't crash. It says, oh, the variable computer choice is declared but never used. See, we got to know what the word declared means to know this error message, to understand it. Okay, so now human choice. Let's go get computer choice. Okay, now computer choice, and some of you will say, okay, it's random.randint. And like you'll notice that random doesn't have anything cool built into it. There's no randint, random number, or no next. You remember the weird thing about random is you have to create a new instance of it, a new random class object. Okay, so you go random, just like you go int or string, you go random, blah. I'm going to call this I did it my rand last time, my random thingy. Okay. If I keep saying my rand or my random, you'll start to think that's a magic word. You could call this whatever you want, but I'm going to call it that weird name. And remember, it goes equals. I'm creating a new variable of type random. I'm going to say it equals a new random. And this is a little bit weird. This is how you instantiate or create an instance of a class, which is a blueprint. Okay, so you could have tons of random classes in your project, but we only need one because we're only making one random number. Now that I've created my random thing, I'm going to hit tab. Okay, we need to start using our autocomplete. The second it only has one choice there, or actually any choice there, if I hit M, oops, the second I hit tab, it autocompletes. So I have to narrow it down to, okay, that's what I want, my random thingy. And now I can hit my dots and see what random has built in. And do you remember what it was? It was, oh, my random thingy dot next. And do I want arguments? Yeah, let's choose between 1 and 3. Max value must be greater than or equal to the min value. Max value is the exclusive upper bound, so it's not going to choose a 3. I need to go 1 to 4 so that I can actually get from 1, 2, and 3. Okay, let's print these values out just so I make sure. Console.write, and it'd be better if I did it in a for loop, just so I could see all of them. But again, if you start using your tab, I just type COMPU, and then the second it got to one choice, I hit tab. It saves you a lot of typing in the end. Okay, so the computer chose 2. Let's see if the computer can ever choose 1. It chose a 3 that time. I'm choosing the top number. I'm going to choose a 7 this time. There we go. Computer can choose 1. Okay, now the question is, can it choose 0? I hope it can't, but I don't think it will. Okay, so we're done here. We got the computer as a random number and me a number. And you're like, that was kind of a lot of work. But now that we have 2 numbers, you need to start thinking, what are those numbers? Okay. Now we're going to do this the hard way and an easy way. Okay, I'm not going to show you 1,000 ways to do it, but I'm going to show you one that doesn't quite make sense and one that makes a lot more sense. Okay. So we need to check their answers for a winner. We have 2 numbers that we got, and you're like, whoa, numbers? The number is the rock? And like, yeah, that's how computers think, right? They think in terms of strings, maybe, but easier for them to understand are numbers, and easier for me to compare as numbers. Okay, so let's go. If, you know what, how many unique possibilities are there? I can choose 3 things, the computer can choose 3 things. 3 times 3 is 9. Okay, there's a chance I would have to do 9 ifs down here. Okay, if, and let's do it in pseudocode. If I chose rock and the computer chose paper, then I'm just going to hit the next line, console.write line. What happens if I choose rock and the computer chooses paper? Player chose rock and computer chose paper. Player wins. Okay. And that's it for the output. Let's go change it. I chose rock. What does that look like? I chose rock. Well, I need to say if my choice, or the human choice, equals rock. No, equals, oh, what was rock? It was 1. I had to look up here and see. Human choice equals 1. And computer choice chose paper. Computer choice equals what's paper? Okay, it's going to be 2. And you're like, well, that's for the human, but yeah, the computer's numbers have to be the same thing for this to work. Random number 1 means the computer chose rock. Random number 2 means the computer chose paper. Random number 3 means the computer chose scissors. And that's how we're going to compare them. Okay. So again, I got my parentheses around my comparison. If human choice equals 1 and computer choice equals 2, then console.write line, player chose rock and computer chose paper, player wins. I am not going to put my curly braces here on this program because I want to try to fit it better on a smaller space, a smaller screen. So yeah, I'm not going to put those. Let's run this. And the thing is, I'd have to run this a lot of times, but let's try it until it works. You know what I can do? I'm going to force the computer after to do paper. Okay, so even though it gets a random number here, after it does that, I'm going to force it to be paper, just for testing purposes. Okay, unexpected, parenthesis, did I get an extra one? If, okay. Oh, and I got an and here, sorry. and is not a valid word in this programming language. Do you remember what it was? It's double ampersand. Okay, so I choose rock. The computer, it says 1, but that's what its random choice was. After that, I chose paper. So that's why it says player chose rock and computer chose paper, player wins. What if I do anything else? If I chose 3, and then the computer says it chose 3, nothing happened. Okay, so again, I'd have to do 9 of these. Now, can you think of a solution to take care of 3 of them that are easy? Okay, so before I even take care of paper and rock or whatever, what situation if, let's copy this. If human choice, and you know what, I'm not even going to use an and. What if I chose the same thing as the computer? What happens if we both choose rock? Both chose the same thing. It's a tie. Okay, so when is it a tie? You're thinking, well, if I choose 1 and computer choice equals 1, let's try it. Oops, and let's force them into it. Let's force the computer to choose 1. And I choose 1. Both chose the same thing. It's a tie. Hallelujah. Okay, and you're like, yeah, but then you're still writing 3 of those. If we both chose 2, and you're like, well, this is rock. Both chose rock. I'm trying to make my life easier. What comparison means we both chose the same thing? This is too long. I'm going to get rid of some of this. See if you can pause the video and figure out what needs to go here. If we chose the same thing, what does that mean? Human choice equals computer choice. Let's try that. What is if I choose 1 and the computer chooses 1, 1 equals 1. Oh, is that true or false? Okay, 1 equals 1. That's true. Okay, so that's what's happening. Remember, these variables get replaced with their values. So human choice up here, is whatever they typed in for read line. What was computer choice? Well, it was a random number between 1 and 4, but then you erased it and said computer choice equals 1. So let's run it. 1. And I know this is not right. The computer chose 2, but then afterwards I forced it to be a 1 right here. So let's get rid of that force, and let's keep going. Okay, I just took care of 4 situations. Okay, I only have 5 more, and you're like, that's still a lot, but it's going to get easier. Okay, I'm going to get rid of spaces between them in a minute, but we'll keep them spaced for now. I'm going to paste this. If human choice equals 1 and computer choice equals 3, let's do them in order. Player chose rock, that's still true. 1 is rock. And computer chose paper. What's paper? That's, this is scissors. Okay. Player still wins? No. Scissors. Wait a minute. I have not played this game in ages. Okay. Player wins, rock beats scissors. So this is not correct. Computer chose paper. Paper beats rock. So computer wins. Okay, there we go. So we got tie. We take care of all the rock situations for the player. Now let's go take care of the rock situations for the computer. I'm going to copy these. Actually, I did, right? Player chose rock. Okay, let's go computer chose. Oh my gosh, this is getting confusing. Player chose, let's just put paper in here. Paper. Okay, and this is not paper. What's the other? Rock. Paper versus rock. Okay, I'm just trying to plug in combinations I haven't chose. Now I have to swap the numbers out, okay? Before I go any further, I hope you realize what a big pain in the butt it is to say, okay, what's paper? Paper, look up here, paper's 2. And then swap these for numbers every time. Okay, I'm actually going to back this rock on up. And instead of putting 1s and 2s here, do you remember what I just said like 2 minutes ago? That when the computer sees computer choice or human choice, it plugs in the number that's in there. What if I don't want to have a 1 here all the time and a 2 here all the time, but I want a variable that has a 1 or a 2 in it? Okay, for instance, this 1. Wouldn't it be easier if I called it rock? And if I called this 2 paper? And you're like, whoa, grammar, can you do that? No, I can't right now because they turned red. What does red mean? It means let's run it. it'll say rock does not exist. Rock is not defined. So I need to go back up to my variables. I'm going to make 3 more ints. Okay, and I could put them on different lines, but let's try to put them on the same lines. Actually, I don't know how to do that in C#, so I'm going to put them on different lines. Int rock, int paper, int scissors. Okay, and you're like, oh, let's go give them some values right now. What is rock? It's 1. What's paper? It's 2. What's scissors? It's 3. Now, in my program, wherever I would have had 1, 2, or 3, I could plug in, except for right here. I don't want to put rock and scissors in there. But I could put in the word rock and the word paper. And please note, my red went away. This works now. So what's the 1? It's rock. And 3 was scissors. But from now on, I can just do the human readable thing, okay? So let's go rock versus paper, rock versus scissors. And now I'm going to copy and paste. And I'm going to switch those around. Let's go paper here and rock here. And paper here and scissors here. Okay. So now I just have to, okay, this word player chose paper, computer chose rock, and who wins? Well, paper beats rock, so player wins. Okay, so let's see if this is right. Paper, paper, and then we got 2 more, right? Scissors, scissors. So let's go try it. Oh, actually, do I have the right one? No, I have the player winning all the time. Paper does beat rock, but rock does not beat scissors, so that's computer wins, right? Okay, and I should just stop right here and make you finish it off. You know what? I'm going to do that. You need to do the rest. Remember, there's going to be, this takes care of 3 situations when we tie. That's 1, 2, 3, 4, 5, 6, 7. There's just 2 more. Let's run it a few times. Oh, and let's get rid of the, I'm hitting Control-C to break. Let's get rid of this where it forces, oh good, I already did. Okay, run it, save it. I'm going to choose rock. You always choose rock. You never choose anything else. Rock is obviously stronger than paper or scissors. If you choose rock, you will win every time. Player chose rock and computer chose scissors. See? I just told you. Let's run it again. Choose rock. Player chose rock and computer chose paper. Player, wait, what? Paper beats rock. Okay. So let's run it a few more times until we get what I'm looking for. Let's do 3. 3 versus 2 and nothing prints out. Okay, so I chose scissors, the computer chose paper. I should have won, but I didn't take care of that with another if. Okay, and remember these can be else ifs, it doesn't matter, but ifs are fine. Could be only mainly because these are all different combinations. There's no possibility that it could be 2 of these. I couldn't have chose 3 and 2 at the same time. So anyways, that's great rock, paper, scissors. I hope you liked this video. I hope it was helpful. I am going to scroll down through it one last time so you can compare your project with this project. Those of you who are fast forwarding to the end of the video, just remember when we take the test, you won't be able to do this as well as if you'd followed along and learned some of the stuff. One more heads up. Later on, we will learn about a thing called enums, enumerated types. That's basically what we just did. We swapped a word for a numeric value, and from that point on, we just used the word, and it made our program a lot easier to read than using 1s, 2s, and 3s everywhere. Okay, so these are actually built into C#. These are not actually enumerated types, but we're using them like enumerated types. Okay. All right. So let's scroll down. Here's my main function. Again, I carved out my programming space in the middle. And here's the whole set of code I got right now. It's not quite done. Some of you will want to put this in a while loop and keep going until they say rock, paper, scissors, or Q, or quit, or 0 for quit, or something. That would be kind of interesting. But yeah, fun game. Let me know if you have any questions, and thanks for watching.